and right, left and right. So, screen, hard right, hard left, hard right, hard left, a little bit in between, just a little bit in between. Oh no. So it won't let me cross the white line, but yep, she works. A few weeks ago, Zwift and Elite released the Sterzo, a electronic steering mechanism for your smart trainer. And this is the only device that can enable steering on Zwift. Well, I mean, you watched the beginning of the video, so you know it's not. But there was a bunch of hiccups on that road, and I thought I was just going to buy this thing and connect my cell phone to it using one of these dev tools like NRF Connect, and hit notify and get back information, figure out what that protocol was. Interestingly, I couldn't do that. Now, what I mean is you connect to this, it looks like a dead device. It doesn't transmit anything. You can't get notifications of anything. You connect a heart rate monitor. You might not be able to decode the data, but if you hit notify, you can get heart rate data. And it may be encoded in some way, and you have to figure out that encoding, but that's why there are standards. In this case, this is all made up and all proprietary. It's all proprietary between Elite and Zwift. And I didn't like that as a concept, especially with how ambiguous FutureWorks has been. I tried to do the cell phone steering, but I wasn't invited to FutureWorks, and I tried to ask them about that. And when I originally ordered this, I contacted support and I said, look, update to the latest version of Zwift, no steering icon. How does that enable? How do I join FutureWorks? Well, 6 emails back and forth, they never gave me a straight answer, and I said, look, I'm buying it, so I will call you when and if it doesn't work. Well, to my dismay, it just worked. And then I found out that you guys are doing something nefarious. So if you enable Bluetooth, they basically have full range of Bluetooth to do whatever. But normally when you click scan for sensor, then it starts searching for a sensor. Not so with Sterzo. Without any of your direct permission to scan for any sensors, if it has access to Bluetooth, Zwift will scan for the Sterzo. Or other things, we don't know. Basically, it is very similar to using your webcam and not telling you. They're using a piece of hardware without explicitly explaining that. I've gone through their website. Doesn't say that's how it works. So there's gray area, there's loopholes. Basically, they've loopholed themselves that, you know, if you give them BLE access, they can do whatever they want. But suffice to say, without your knowledge or permission, when you start up Zwift and you get that steering icon, it has, without your permission, searched for and connected to a sensor. Now that was a second layer of annoyance. So that kind of made me even more desireful, if that's even a word, to reverse engineer this thing. So I was fortunate enough to actually have a proper Bluetooth developer reach out to me and say, hey, do you want some help on this? And I said, sure. I didn't actually know who he was until like 30 emails in, but he was Andy. He works at a company called Punchthrough Design. They have lots of great blogs on just development of the stuff. Their original founder, I believe his name is Colin, had lots of stuff that I kept referencing over the years for like just tuning your antennas and stuff. So that led me, once I got it, to connecting my cell phone, and it didn't work. And I was very annoyed about that. So it didn't work, but it worked in Zwift. But it also said the word activating once it connected to it. And I thought about that. So time for me to break out my Bluetooth sniffing skill set, of which I had 0. So I actually basically learned this from scratch. I sort of used this stuff a long time ago, but not for BLE. So Wireshark and the Nordic Dev Kit allowed me to snoop both sides of the conversation. And it was through that me and Andy were able to basically determine a handshake. Interesting. So the handshake's a 2-byte code that is randomly generated by the Sterzo that you require the right authentication, right response. You require a 2-byte correct response to get the Sterzo to talk. But that uncovers something interesting. You can make your own sensor and not have to worry about any of this authentication stuff at all. And so by doing that, you don't actually have to break any authentication. Now, I wasn't going to just leave it at that. So using a tool that Andy wrote, I went and I brute forced and got all the codes required for authentication. So we've snooped sides, we see it back and forth, and it was late one evening and we couldn't figure out the data coming back that Andy realized they're just floats. So he was able to whip up a demo that used buttons. I forked from his GitHub and added analog reading. And so now if you go into either of our GitHubs, you can just download and compile the code that allows you to use this. And that's really great. So we might demo that a little bit again, but I wasn't happy with that. I mean, this is a simple device. So I figured, let's take it apart. So I did. And then I saw the circuit board and I figured, let's see if we can read back the firmware. So I did. Then I went on a little bit of an expedition to find what sensor are they using. So I did. So without further ado, let's get into going through each of these points. It's going to be a bit of a long one, so jumping to relevant sections is totally okay. Basically, everything is a bit of a tutorial, so I'm going through how to set up Wireshark, I'm using Wireshark, and what I have to do to see into the Sterzo. Using Andy's code, which is also on his GitHub and my GitHub repositories. How do you get that working? The compilable code for the Nordic chip is there, so if you want to replicate that. And all of this stuff, I don't really recommend doing, but honestly, like, Elite, lock your firmware? So I just wanted to first demo. This is NRF Connect, and we're just going to connect to this heart rate monitor that I'm currently wearing. And we can download the name and the appearance and how often it's talking, so 250 to 500 milliseconds. And we can download the battery level and set notifies. So those setting notifications, setting it there now for the heart rate measurement. And it's set. And there we go. So now we're starting to get notifications, so 72, 73, 74 BPM. And that's going to keep updating. And that's how these characteristics should work, is once you tell the device you want it to notify you, you will get new data at a prescribed rate. So let's go back to the scanner. And you can see the Sterzo there. Actually, let's just refresh that. And Sterzo. So same thing, device names, appearances. We can download these parameters, a little bit faster connection interval. Experimental buttonless DFU. Shouldn't be experimental. I mean, that is an antique if it's experimental. But this unknown service, this is the one we're looking for. So unknown characteristics we can download them manually, and we can set notifications. And basically we're getting nothing. I'm moving it here. It's not producing any data. Nothing at all. So we should be getting something out of the 31, but nothing. And it's not like it's not working. We're set the battery service notification, and a bit slow. It's downloading. It's working fine, but nothing. We're getting nothing else out of this thing. So it's basically entirely dead in terms of a BLE connection out of the box. So that leads into the next bit with Wireshark listening in. In order to figure out how the Sterzo actually works, we're going to need, one, the Sterzo, and two, something that can see both sides of the conversation. So the other side of the conversation is just going to be the same computer I'm doing this on. We need something that sees both sides, and ostensibly they're called a packet sniffer, or a Bluetooth packet sniffer in this case. I don't actually have a dedicated packet sniffer, but a Nordic 52 series DK kind of fits the bill. So Nordic has written BLE packet sniffing tools that work with Wireshark. So you need to get Wireshark working. And honestly, if you do a search, ignore everything at the beginning, all the dev zone stuff, which is where you'd expect to see things. Ignore the Nordic how to get things working. Just jump straight to Jimmy Wong IoT. This is probably the best simple handhold how to get this working. And yeah, it's not actually hard, but basically you need to have your Python installed, you need to download Wireshark, you install it. So Wireshark is a generic packet sniffing tool. In this case, we're actually going to be using it for this, beat this Nordic chip. The difficulty here is Wireshark is not originally set up to do this. So we're actually at this stage here where, all right, we need to program the code. So I've got it in my downloads here, assuming I didn't change anything. Yeah, okay. Turn on your device. But one of my favorite things with NRF Connect is you have to restart it. So we'll do that. We'll add our Bluetooth sniffer. It's just reading back the chip. You can see that I've got some sort of application here that's, you know, about 128 kilobytes long. Something else here. Have no idea what that is. Go ahead, erase and write. This is actually slower than the command line version, but doesn't really matter. All right, there we go. So in Wireshark, I've actually got this already configured, but let's just start it again, initializing externals, and now you can see that we have the sniffer. So you have to follow Jimmy Wong's stuff here. Basically, config about Wireshark, go to your folders. He's got a slightly older version, or just by something like 0.1, but I don't know why, but there's a personal XCAP path and then a global. You actually want to put it in the global. So you can see all my sniffer stuff is placed in here, no big deal. Once you do that, you make sure I've already tested this is running. The personal configurations, there's XCAP profile, so the profile here, and then you basically, I think you should be good except for over here, the configure profiles. This should show up then, and then you can run the sniffer. So now that I'm here, I have this, I can double click it, and it's already starting to scan. So it's already capturing all advertising packets, or it should be. All right, I had to restart it, so make sure that your Nordic programmer isn't written, and you can see that we're just getting all these packets here, and now we can actually see things. You can see my tax flux, so now I can limit it to just seeing my tax flux, and you can see the advertising packets, and what you can see, advertising data, manufacturer, manufacturer specific, data, flags. Let's go ahead and make this a little bit wider. So yeah, it's just advertising. So these are just advertising packets saying, hey, I'm here, I'm here, I'm here, and it's doing them fairly frequently. So you can see that it's about every 250 milliseconds. Brain mathing is hard. So we've got that. All right. And so we can see other things. You can see some TV that I don't own. That's obviously a neighbor's or something, a bunch of random stuff. I have no idea what PRBT, this has been here for years, and a bunch of things that don't say what they are. A lot of times they're just computers. All right, so Zwift. That's probably going to get angry about me for lots of reasons. So I'm currently not even actually paying for Zwift right now. I'm on my summer hiatus. So you'll notice this whole time I have not moved the Sterzo. The secondary camera capturing that there is no blinking over here. We're gonna make Zwift hopefully look wonky. But you'll notice now, steering is grayed out. But it has seen it in the past. That's not a big deal. So we'll yeah. So now I'm going to move my Sterzo. I'm going to have it start searching. And the light is flashing. Sterzo. So we see it. And so what's interesting now is see, and this is the interesting. It's already connected to it. But I guess I didn't get the packet. So hold on. So this close Zwift. Okay, so I had to disconnect. I had to disconnect because my sniffer was not seeing the Sterzo. So I'm just going to cheat. So now we have the Sterzo. Scroll to last. There we go. So this here is just the Sterzo, CF04. So these are our advertising packets. So now we start up Zwift. So this is one of the pain points, is you have to be able to reset everything over and over and over and over and over again. So we just had to reset Zwift. Well, you need it, Sterzo advertising and Zwift not to have talked to it yet. And that was key because part of what we'll see, you see it says activating. So it's already connected. So I don't really need to do anything else because now what we can see is we're getting these notifications. So it's updating the angle. As I rotate it, it goes, negative 34 degrees. Positive 32 degrees. Okay, that'll help my calculations later. So we're getting these packets and we're getting handle 002A. So the handles mean vaguely nothing because they're defined by how many UUIDs. So I might get some stuff wrong here. Please forgive me. I am not a Bluetooth expert. I know Ant Plus much better. And a lot of the figuring out, I mean, I have to give credit to Andy. Andy did, he took a lot of the packet stuff I sniffed and he ran with it without a Sterzo. So he's much more clever than me when it comes to this packet sniffing. He's a proper Bluetooth developer by day, so he knows what this stuff is. But you'll see that UUID, this is the service ID, and you'll see that it's coming back on UUID. Basically, these numbers in here indicate your kind of your sub UUID, so the characteristic ones, and we're on number basically 30. So we're getting a value, and we're getting another value, and another value, and like all of them have these values here that frankly, like when you're looking at them, they're jumping around all over the place. They don't seem to make a lot of sense. We'll get to that. But what we want to do is we want to scroll over here. So we went from advertising. No, I need to learn how to make my actual keyboard work. Okay, so we're advertising, and there we go. So this is the whole crux of everything. It's going through here and saying basically it says, all right, Zwift says, start telling me all your handles so that I can enumerate and know every single characteristic that you have and every single service you have. Oh, okay. I'll send you this one. Oh, and this one has a where's the handle listed? Receive type, a group type response, yeah, end handle is 0009, 000D. And you can see all these. All right, so these are 3 profiles there. All right, let's get the next handles between this. And so every time it gets one, it increments. So this one is going to be handle 12. So then it says, give me your next one, and it gives it the next one and the next one. And we keep getting these service declarations. A lot of these, it knows what they are, blah, blah, blah. Like this is the battery level, battery service, central addressing. We have to keep scrolling down, And now we start getting these unknown handles. So if we go in here, we'll notice that service ID is 347B0001. So, or 17. That's what we want. Okay, so that's that weird unknown that we had when we started this whole process. So it's getting all the characteristics. All right, so it's listing them all. This is just standard Bluetoothy stuff. Hits an unknown, blah, blah, blah. And we start getting all these things, but then we get these write requests. Now I must have missed a write request. There, yes. All right, so this one you can see the master, i.e. Zwift, sent to the device into 31 the value 0310. All right, pretty innocuous. Response that, yep, got it, I'm going to deal with it. And then the Sterzo slave, so the source of the slave, the Sterzo, it comes back into UUID 32 with a 0310 D4B4. Okay. That's interesting. So we already know, like, if we just did everything up until this point without that, Sterzo gives us nothing. So this seems to be key to that. And then Zwift says back, the master, Zwift, says back into that same 31, 03112106. So Zwift sent us 0310, so 2 bytes, 0310. And the Sterzo said 0310 junk, 2 more bytes. And then we wrote back 0311 2106. But it's those last bytes I realized are related to what the Sterzo says. So the Sterzo is generating a random set of 2 bytes, and Zwift has to say, this is your response. So that's a challenge. Here's your handshake. Here's the really dumb thing about that. That only prevents my software from using the Sterzo. It doesn't prevent me or anyone from using a fake thing, because we can always just generate, and in our case, what we actually did, what Andy chose to do, is generate 03101234. Zwift is always going to give back the exact same response, but we don't care about those last bytes. We're just gonna, if someone gives us a 0311, we're just gonna turn on and start streaming data. Like, it's stupid if we don't. So there's no secure, like, the security protects from using the actual Sterzo hardware with other software. And this makes no sense to me in terms of exclusivity. So if we ran, and I ran this capture many times, I'm going to stop it now. I did this several times, and every time the number changed, every single time the number changed. So in trying to get past that point, that's where Andy did something kind of amazing. All right, so this is basically where Andy really took over. So what I mean by that is he basically wrote everything here. He has a, I believe it's on the Punchthrough website. Hopefully I can put it down here on what he's basically done. So he's kind of using a, what is it called? It's a there's a BlueZ wrapper around something. Yeah, so there's this Dbus thing that uses BlueZ, which is Linux interface. So as you can probably see, I'm in Linux on my laptop here. I'm actually booted from an external USB drive. I have Linux on my main desktop, but I just this needed to run for quite a while, and I'll explain why. So what he's done is he's basically built a framework where he can add all these characteristics and define what they are and how they work. And so he's got a bunch of debug stuff in here. It's really good. And this is those values, those characteristics. So basically what it's saying is if we get a value of, as I mentioned, 0, 3, 1, 0, so they're hex values, the logger will say, got it. And then give us the value. Well, what I added is that we're going to actually transmit, when we get a 310, a 0310, we're actually going to say 0310, but also a few other things. So we're going to, I have a counter in here, and it's currently set to start at 46A7. It was just where I stopped it and restarted it at some point, but we'll run it again, and it takes those two values and it throws them out to here. And then if we get a 311, it's going to tell me what those responses are. So the only thing I found that this works on, I don't have any iOS devices, and Andy had problems working on iOS devices as well. It seems the desktop version doesn't like the simulator, but the Android version seems okay with it. So here we go. So the phone is running. I can't do a screen cap and Zwift at the same time. It really chokes. And I'm going to run this. So it's looking for sensors, and we're advertising, and this is a bit dicey. So steerer is the current name, and as you can see, we can start getting here. So for 46, we've got a 70 and a 160 response. Oh no, sorry, that's what is in hex values. We got a 65 and a 39. But keep in mind, these are not in hex, these are in decimal, so eventually I have to run a parser to capture, and all this is being captured in a log. So we take this and we parse through it. So the two info lines, bit kind of ghetto and hacky. Andy's code is elegant. I just kind of took a big hammer to it. It just keeps running through, and you will notice that 8 seconds, 19, 27, 35, 27. It takes 8 seconds for Zwift to try again. That means 24 hours a day for 7-ish days to get all 65,536, I thought originally, but 35 codes. Seems FFFF is an invalid code, and I don't know if that's a BLE thing or if that's a Zwift thing. So it thinks we're all connected over here on Zwift. It's just running through. So Andy's contribution really was to get this actually doing stuff, and once he had it, he was able to, he replayed the Wireshark data. So he extracted the Wireshark data for the characteristic, the one that looked all over the place, and it played back fine. So we knew two things. We knew that those 4 bytes that it sent are independent. They don't require event counts and in some byte field, and they don't require accumulators and others. They are independent. They are just saying, here is my angle. And we're looking at it, and we're looking at it, and we're looking at it. And I tried every way to try and decode it, and I started like moving it and holding the Sterzo in different positions. And then Andy had a much smarter idea than I could have ever come up with. Knowing that it's little endian, he took the 4 bytes and he threw them into a hex to float converter. And that basically worked. So he realized that they're just floats. You're just sending out 4 bytes. It's a float. I mean, in the little endian method, but it sends 4 bytes. So now we just need to generate an angle in float, in a 32-bit float, and transmit it. So we have the framework now. We don't actually need these codes to replicate it, but if we want the Sterzo to talk for other applications, we need those codes. So yeah, pretty much amazing work on Andy's part there. Yeah, so let's take what we did, connect to the Sterzo, and let's make it talk. So we know it's this unknown service. We're going to set notifications on these 2 characteristics. Going to send 0310 sent. We get back 4453. I'm just going to look that up in my text document here. I mean, there's 65,000 codes here, so yeah, hold on. Bear with me while I search for it. You have to maintain the connection. If you disconnect and then reconnect, it's going to generate a new code. So you have to stay connected, but it doesn't seem to matter how long. All right, so we've got that. It's 0311. Let me double check here. 7C61. And there we go. So you scroll up now, and just like the heart rate monitor, it's spewing data back. And if you freeze frame here and you copy and paste that into a little endian to float converter, you'll see the angle. So I'm just moving it back and forth. But yeah, it basically looks like gibberish. Sometimes it sends a 0202. Nope, a 0202 command. But yeah, or it always does, but we don't seem to know what it's for. It doesn't really change anything. So we don't really bother with it. But yeah, we know how to make the Sterzo talk. All right, finally we're logging in there. I've got a simulator on my other computer for the power meter. I've left the naming for this is Marl, and as we can see, everything should be connected. There we go. Okay, a little bit stupid on my part. Just replugged this back in and had it plugged into the wrong port. So you can see here, I just increased the sensitivity so you get much more steering angle. So yeah, let's search for power source, not the tax flux. All right, there we go. We're actually going to unpair that. We're connected on steering. It's going to turn down that power to like 200 watts. Ta-da. And we're going to, I've got my little steering nubbin here. It's giving me some warnings about future work steering, blah, blah, blah. Click OK. And now you have to get out from a bunch of the people to actually start steering. That was a bit annoying. My laptop's chugging here. But yeah, like sometimes steering just doesn't do anything. Like there in the intersection, it just doesn't do anything. So you can very clearly steer with this, but I'm just going to rip this all out. It's probably going to go fly off to the side. Now here we are with a little joystick. Oh, don't have my axis correct. Steering left, right. Oh, I think I might have it too sensitive. So you can't choose routes via this, as Zwift has been very clear, but you can steer with it, or, you know, with what me and Andy has created here, you can steer with this. So not being fully content with All right, we've broken both sides of the BLE proprietary protocol. Again, the 100% unnecessary. Should have just used GAT. Should have just used HID. We're going to take this apart. And I don't know if I need to take out the batteries, but yeah, I'm going to have to start with that. Basically, this is the most annoying thing in the world. There is no way to put in the batteries where they don't jump like this. We'll take them out for now. Beyond that, there are 6 screws. They're all the same type, so these 3 here. Basically they're self-tapping plastic screws, but they basically look like wood screws. Actually, I like to leave these together. So heavy duty, nice heavy duty foot. So what do we have inside a Sterzo? All right, when you undo this, flip it towards yourself, because these cheap pieces of tape hold the battery compartment wires. Now we'll want those. Now there was a sticker on this. I'll probably throw that on screen. So this board contains only a few things. This, likely the power regulator. These are probably NFETs with inline resistors for this. So these are meaningless. This is meaningless. And all we've got down here is this. And this sits directly below this magnet. But what you'll find in here is that this is a footprint for an ISP1507, probably an AX series module, which is a Nordic chip with oscillators and everything built in, pre-certified. This is the Dynastream version of it. And with the Dynastream version, what you usually can do is you can pay Garmin an extra fee and they'll do a bunch of work for you. So they'll provide you with like a BLE library with things already mostly complete and sort of working. These 2 lines here run over to here. So what we're likely looking at is a potential cost-saving method. What they're trying to do is they want to get off this chip and move to the ISP in the future, potentially, to save some money, because these ones are about $6 to $10 more expensive than these ones because of those Garmin fees. They're offering you support, they're offering you libraries that you can't get without signing away. Because of that, these are usually a bit more expensive than these. Now, it just might have been that they were just trialing the 2 and left the footprint, because this is a pretty cheap board. It looks like 1.6 millimeters. It only has the 1 sensor. So they've likely ran absolutely, teetotally every single thing parallel. So, and likely to the same pin. So the pins for this chip likely go to the same points over here, which are these. And these programming pins likely go to the same points here. So there's 4 pins you need to program. You need power, ground, and 2 programming lines. So that's what we've got here. You can see I've already marked this one's VCC. This one connects to this pad here, so it's ground. If you actually measure continuity between the black wire and this, I might be able to show that. There we go. 0.3 ohms. There's some flux residue here. So let's solder up some wires and see. Now, an experienced company or programmers they'll have used the latest SDK, and they'll have at least locked out read back of the chip. Who knows? Maybe we'll get lucky and it's not. So power ground, one of these is going to be SWD-IO, one of these is going to be SWD clock. So single wire IO, serial wire debug interface. All right, so as you can see right here, we've got the device. I got lucky on the first try again. Blue is for ground, black is for power sense, and I guess green is for SWD-IO, and gray is for clock. So open up our programmer. Let's select the device. And it's actually reading something back. And look at this. Fully unlocked. See the soft device. You can see where the bootloader is down here. The little, or the code that redirects to the bootloader that's up here. So this is pretty standard Nordic dev stuff. It's all unlocked. So, just going to navigate to my documents, nrfjprog, read code to sterzo.hex. And yep, I'm reading the flash. And so I now have a fully 100% identical copy of this this hardware. So I could theoretically, if I was nefarious, I could take this and download it to another device. But what you might say is, well, yeah, but you know, if you look at this here, you don't know what this chip is. But knowing that it's a 6-pin magnetic sensor, you can kind of figure it out. So that sensor is a TLV493D-A1B6, because this is the only non-automotive sensor they use. And what we know is an ultra low power 3D magnetic sensor, or kind of like a compass, but with the magnet above it, it forces the angle and then it gives you an absolute angle. How do I know it's this? Well, if we scroll down the datasheet, we see 6 pins. Most of these devices are 8-pin. It's unusual to have a 6-pin, so pretty good chance it's this. But not only that, my favorite is the application circuit. Normally with I2C devices, you require 2 pull-up lines. But this very clearly wants inline resistors and a capacitor. So we have 1, 2, 3, 4, 5, 6 elements here. And right here, what do we got? We have exactly 6 elements and a decoupling capacitor. Ta-da! So 100%. Now, as I pointed out earlier, everything is likely wired in parallel. These pins over here are the same programming pins as these ones over here. So I measured continuity, they are 100%. So I can program this chip, and I've measured continuity between these back wires to here. It is the same. Let me swap focus. Now, this chip is likely wired in the same, and they connect to pins up here. If we look at the ISP 1507 datasheet, ISP 1507, miniature low, Bluetooth low energy, junk, find a datasheet, lazy, pin out, oh my god, it's not called pin out. Pin description. Let's get a picture. So, right back here, and right to here, we can probe from this point to over here, and we'll find out what pin is connected to, and then we can correlate to what pin it is here. And so I'm not saying it actually is, but let's just say it's 13 and 15. We go up to 13 and 15, digital I/O, it's P021 and P020. Probably not those ones, but as an example. So we can find exactly which pin it is. And if you do that and build your own little board with this chip, or not with this chip. So if you build your own little board here, ignoring all of these, just put on this and a NRF52 module or chipset, connect to the same pins, you should be able to take the Sterzo firmware off of this, download to your own device, and just use a magnet to steer. Lock your readout, guys. lock your readout. That was not something I should have ever been able to do.